In the dynamic landscape of the mining industry, the pursuit of sustainability has become both a challenge and an opportunity. As the sector gravitates towards an eco-friendlier future, mining and technology companies are at the forefront, developing innovative practices and solutions with safety, efficiency, and sustainability at their core. Please welcome the speakers of the final session of the conference, who will present groundbreaking solutions aimed at enhancing safety, efficiency, and productivity in mines.
Thank you. Well, good afternoon, everybody, and welcome back after lunch. This afternoon's session is a technical session. We've got some excellent speakers lined up, talking on a variety of subjects. Just want to say that the sessions so far have all been excellent. There's some particularly good presentations in the earlier sessions, particularly like the videos of the mining companies in Kyrgyzstan and Kazakhstan, all very, very good. So, without further ado, we'll move on to the first speaker, Harald Bornebroek from Nerospec SK. He'll be talking about some of the innovative electronics that his company designs and manufactures with an end view of improving the safety of mines. Over to you, Harald.
Yeah, thanks a lot, Richard. Thanks a lot, Richard. Welcome, everyone. I hope you had a good lunch. I think for some of them it was a bit too much by the size of the audience, but I think it's very important as well here we talk about sustainability. But even as important is, of course, safety of the people working on the mines. And that's actually the background and also the ground from the reason why Nerospec was founded many, many years ago as a South African company, and I'm a representative of that company. What the company does is that we manufacture components, electrical components, that makes miners more safer and more efficient. And we do that OEM agnostic, so we're independent to any type of OEM supplier. And also independent on any type of mining operation. I will show you some examples. And I have to watch the timer. There it goes. All right. What is the vision? What I said is to make mines, machines, and miners more efficient and more productive, and we're going to do that, and we're doing that by making use of the modern technology, what is already existing in the market, and we combine that, or we develop and engineer and manufacture that ourselves. What I said, the big drive was on safety, and the number one killer in the mining industry is machine-to-machine interaction and machine-to-pedestrian. 30 to 40% of all the fatalities within the mining industry are related to that. And in 2012, an organization was grounded, which is called the EMIST, Earth Moving Equipment Safety Roundtable. There was a consortium from all various big AEMs like the Komatsus, Caterpillars, Sandviks, and also big mining houses like the BHPs and Rio Tintos, and including technology suppliers, of which one of the first one was Nerospec. And as you can see at the last slide, actually just from the internet site, it says 30% of industry deaths are attributable to failures of vehicle interaction controls, and of these, about half involve pedestrians, mostly in underground. For obvious reasons, of course, underground, noise, visibility. So a solution had to be brought. Here's some pictures of examples of accidents, but if you Google on the internet, you will see more and actually recently, last week in Brazil, another miner was fatally killed in a machine accident. So what did the Earth Moving Equipment Safety Roundtable come up with is levels of intervention of controls. Number one is, of course, when you start designing a mine, is on your travel roads, your travel ways, where you try to minimize the potential of machines coming into contact with other machines. To do that, that's level one. And eventually, where you see down, you come to level 8, that is something what we had in old cars, is like parking your car, you will hear the speaking sound that you're close to a trigger zone. And then it's a warning. And nowadays, there are now 67 suppliers of proximity detection systems. They give you a warning in the cabin that there is either a machine close by or a person. But that wasn't enough. It's the same in your car. If you start barking or the car in front of you and an alarm goes off, you have to close, and if you don't pay attention, you've got your radio on, whatsoever, you still have an accident. And they say, we need to find something for that as well, which is called MS level 9. And that means interlocks. That means it breaks, the machine will take over the human control. Slow, stop, roll back, and retard is all type of hardware that gets it activated on that typical machine. And how we do that? That is what Nerospec has developed in 2014, the first time we call it the Nero Hub, which is a controller. In the middle you see safety, the block, unfortunately the pointer doesn't work, but there's that safety, and on the left of it you will see CAST TVM, collision avoiding system, trackers, mining machine level. So this is an interface. So based on data, on signals, what it does get from a proximity detection system. Like now you have to stop, you come in the red zone, the machine intervenes. So we send a signal out to the machine and we can't control this thing. So this is a vehicle intervention controller, the Nero Hub. If you want to go to automation, I will show you some slides later on that one as well. And this is a cyber hub that really replaces the human being. And if you only want to log certain data of your machine, because knowing what your machine is doing in terms of the status and productivity, you can also gather all those data. So this Nero Hub is beside a vehicle intervention controlling unit, also a data storage unit, where you can monitor real-time the performance and the status of your machine, but also look back in the data if something happens. It's like the black box recorder you have in an airplane. So anything what is on a canvas or any type of sensor you have on your machine, you can either see it real-time or when it gets in an area, especially on the ground where you don't have connectivity, in a place where there is connectivity, it pushes the data through, but I show that in the video. So, this picture shows you on the left side just a couple of proximity detection system suppliers. What I said, there is more than 60, close to 70 around the globe. And on the right side you see a couple of OEMs, machines where we already interface with, and so we are in the middle. Modern days now, those the caterpillars, they will have this solution now in it because they bought proximity detection system companies and they integrate it, which is the same with your modern new car, which has, let's say, the safety features on it, adaptive cruise control, so if the car in front of you brakes, that your car brakes automatically as well. So on surface that technology already exists, but in the mining industry not yet, and only the new, over the last 1-2 years, the OEMs like the Sandvix, the Emperors, they will able to offer it as well, and that is actually not on market. The things what we do is retrofitting. Here a slide on the implementation of this Nero hubs on the South African mines. This was last year. Just some examples that in South Africa they say, all right, we have too many people getting killed on the ground, or even damage. And then here are some statistics where the South African government said, all right, we still need to see 8 trackless mining machines accidents, and they investigated on that. And those were on underground mines where this Nero hubs, this MS level 9 level was not implemented. And the chief inspector and the minister of mines, they said, all right, these accidents finished, 0 tolerance. If the mine says safety first, then they have to buy it. No one's going to get killed anymore with the trackless machine when we have this technical capability, these solutions. So they made it a law. We anticipated on that, and that would have been end of 2023, but the minister said, no, we're going to push it forward. So, and you can see at the bottom line, it says fail to save, and that means if the operator fails to interact on warning, the machine must interact, and this is now law. And this MS level now is sort of filtering out through the rest of the world. Some figures on what we've done in South Africa, different 45 different OEMs, 200 plus different models, because the OEM is, let's say, a couple of models, but then different variations. And we are now installing this on a big client in Mongolia, Rio Tinto Oyu Tolgoi, where Rio Tinto is one of the first big mining houses said, all right, I cannot justify when somebody gets killed on a mining operation, knowing that these safety systems are in place and it's even a law. So yeah, I hope other ones will follow suit as well. But that is for me also being here, explaining a bit what's happening in the mining world regarding safety and with this way it also means looking after you people, make sure nobody gets killed. I know that for myself. I used to work 5 years underground. Another thing, well, we have now this black box recorder with all the data what we get from the machine, from the proximity detection system supply, all the other technology what is available, like localization, GPS, Bluetooth tags, all those data. And so, well, let's rather make use of that as well. And you can only improve what you can measure. So we've combined it as well. So Nerospec has developed a dashboard, what we call CMAC, which stands for short interval measure and control. And you can only improve what you can measure. And there those four things come back again. You see from left to right, safety, productivity, maintenance, monitoring, because I've got all the data now of this machine. We've got one machine where we get the data of about more than 1,000 points. I've got a video on it that explains it a bit.
Nerospec SK is the purveyor of connected mine tech, and has evolved mine technology to be able to implement level 9 intervention controls on any machine, regardless of type or OEM. A fully connected mining machine is something exceptional, and Nerospec SK has been at the forefront of developing a complement of mining machine add-ons to achieve this feat. The Nero Hub is a state-of-the-art proximity detection interface and machine controller. It is the control and information hub that interacts with Nerospec SK's CMAC software to offer rapid insights and enabling mine officials to make quick decisions. With a Nero Hub and a complete complement of Nerospec SK's state-of-the-art sensors and actuators, you can dramatically improve mine machine, personnel, and environmental safety. Insights from the completely connected machine help streamline safety, monitoring, maintenance, and connectivity. Looking at the most critical aspect of mine operations, safety. A few of the safety features included are: full level 9 intervention controls are standard with our Nero Hub. Driver access control, a machine functional safety system, and a fire suppression interface may all be incorporated, as well as a comprehensive speed brake and limiting interlock. Monitoring mining machines has never been easier with the Nero Hub and its suite of solutions. The Nero Hub acts as a black box recorder and stores up to 2 years of operational data, allowing you to monitor metrics such as tire pressure, transmission state, temperatures, pressures, brake wear, engine state, fluid levels and flow rates from the data collected. Real-time machine monitoring may be used to assess machine health, operator behavior, and much more. Productivity insights allow decision makers to link up the best machines and operators for the job, as well as offer insight into which machines perform best, allowing for informed future equipment acquisition decisions. This is achievable through tonnage reporting, movement reporting, operator checklists, runtime and utilization, production monitoring, production reporting, and dispatch messaging, to mention a few. The Nero Hub collects, stores, and packages all sensory data before sending it to SIMAC via 3 distinct communication methods. With total underground connectivity solutions, all data is easily accessible and routed to the surface via a wireless access point for SIMAC to interpret in real time. The Nero Hub will push data to the surface for mines with little or no wireless connectivity whenever it is within wireless range. Our machine-side infrastructure-less solution is the third option. In order to send data to the surface, the Nero Hub data is transmitted to a laptop or Android device which relays the data to the central SIMAC server. The Nero Hub boasts industry-leading OEM and PDS-agnostic capabilities that allow it to be deployed on the majority of trackless mining machines, allowing us to boost profits by pumping up your productivity and kitting out your machines with cutting-edge enhanced safety capabilities. For more information, visit us at www.sk.nerospec.com. Nerospec SK. Connected mining works.
Yeah, besides the internet website, you can just after the meeting ask me and get your card. Send me a message or get connected on LinkedIn and send me a message. But another thing as well is automation. If we talk about safety, it's either just to remove the person out of the dangerous area. So we had the hardware and technology of making machines and also fully autonomous. This is an example in a German KNS pillar line where we designed and delivered hardware. We retrofit the machine with the standard package, what looks a bit like this, with the cyber hub and all kinds of other things. We program the unit and then it's operating fully autonomous. These are some pictures of the cyber hub installed with LiDARs, radars, underground localization, GPS, Bluetooth pins, and why you want to do it. And in this case, it was not for safety. It was the mine says, well, I've got very long times between blasts, very long re-entry times, and have a capital piece of equipment, and they wanted to have it operating autonomously by itself after the blast. So the machine comes in after already loading, completely independent. Then the afternoon or the night shift operator comes there and the machine has already loaded, fully autonomous by itself. And I mean really fully autonomous without any Wi-Fi signal whatsoever. So not drive by wire, because there was no connectivity on the ground, especially in a normal pillar line. And the client says this is what we want, and then 21% OE increase. So there was some big financial gains. This is a short slide of all the other hardware what Nerospec supplies in terms of the communication to make the whole system work, tracking, whatsoever, also on the ground very powerful Wi-Fi points, but that was not in the scope of this presentation. And here's a list on some of the companies where we work with, the majority of course South African. But as I said, we are expanding outside of the Sub-Saharan region now with projects in Mongolia, Canada, Australia, and also some of these big mining names. And then I think you're 0-0. Yeah. Yeah. Thank you.
Thank you. I think we've used all up the time on all of that, but there'll be maybe an opportunity for question at the end. Our next speaker, presenting for Stewart, Assay and Environmental Laboratories, is Salamat Imanakunov. Stewart, Assay Environmental Laboratories, an independent analytical laboratory with more than 25 years' experience in geochemical services markets. Main activity of the company is sample preparation, geochemical analysis, environmental samples, metallurgical testing. But over to you, Salamat.
Yeah. Dear ladies and gentlemen, I would like to introduce our laboratory, Stewart, Assay and Environmental Laboratories, located in Karabalta city. It's nearly capital of Kyrgyzstan, Bishkek. Our laboratory opened in August 1997. Our laboratory using different type of methods such as sample preparation methods, fire assay of gold and platinum elements, multi-element analysis, environmental analysis, metallurgical tests, and each. Also, we have good international lean system. This lean system covers all our processes, such as sample orders, analysis, QC, sample storage, and each. Our lean system ensures sample traceability from sample preparation of sample storage, use of barcode sample labels, laboratory balances are connected on the network to reduce the risk of manual recovery errors, transfer of measurement results from analyzers and other instruments in automatic mode, automated of our quality system, use of proprietary links provides operational flexibility. Our laboratory consists 5 departments. First of sample preparation and fire assay, and department of ICP and atomic adsorption analysis, department of wet chemistry, department of technological tests, and inspection tests. Department of sample preparation fire assay analysis use different type of modern equipment, such as crushers, void elite, this rotary splitter, jar crushers, different type from now Schmitz, and different type of sample splitters and pulverizers. LM2, we have 16 pulverizers now, and other equipment such as drying ovens from ESA. This is equipment. If you use all this, our capacity is about 3,000 samples per day, up to 6,000 samples. And fire assay department use different type of furnaces, combination furnaces and fusion furnaces, such as ENG and ENF furnaces from Morgan, Australia, and DFC furnaces from USA. Also, we use microbalances from Medler, Sartorius, and we use 456 cookers from Canadian company Gateway, and flux from Glen International, Australia. And next department, ICP and atomic absorption analysis. We have 3 atomic absorption agents. This equipment if you use this equipment, our capacity for fire assay, we can. Our capacity is about 3,000 samples per day. Also, we have 4 ICP spectrometers, and first working Elmer companies, Optima 5300, and 3 ICP spectrometers from Asia. Also, we have one ICP spectrometer LNFCE from Piésold and two ICP MS spectrometer from Asian. Now we signed contract for next ICP MS last model. Also we have X-ray analyzer, analytical xenium. Now we do silicated analysis in geological samples. Next department is wet chemistry department. Wet chemistry department equipped gas chromatograph agents and GCMS analyzer from Piésold. We have two ion chromatograph, Dynamics 1000 and Aquarium. This department will do different type of analysis in water samples, soil samples, sediments, biological materials, and age. Also, in this department, we use automatic data from metronome, meter and for analysis of sulfur and carbon, we use LEGO analyzers, SC 844 is new equipment, and old equipment is SC 144. Also, for analysis, we use water purification system from Milipore. Next department is technological test department. We do primary methodological tests such as cyanidation test, blade test, gravity test, flotation test, and preparation test. This is preparation area. Main activity of our laboratories geochemical analysis and environmental analysis and metallurgical tests. We have for verification of our methods, we do interlaboratory comparisons or proficiency testing in the company such as Just Dance, Australia twice a year, Garment, Canada twice a year, GOPT and LDC standards in the UK, or research from Australia, rock labs and New Zealand and local provider. We have laboratory has two accreditation and Kyrgyz accreditation system. Kyrgyz accreditation center for compliance with the international standard ISO 17025 and accreditation body of United Kingdom UCAS for this standard too. Also, we have accreditation for compliance with the international standard ISO 17020. It's inspection and sampling. We have many clients, not only Kyrgyzstan, it's from Kazakhstan, Uzbekistan, Tajikistan, and other countries. Our main clients, such as Kuntor Gold Company, Kaz Minerals, Charazav, Kyrgyz Altın, Kassing, Altın Almaz, Allianz Altın, Kazakhstan Mineral Company, Altın Kim, Adaykovsky Redmir, Highland, and Ish. So, thank you for your attention. If you have any questions, I'm ready answer later. Thank you.
next up we have Tony Edwards, CEO of StepChange Global Consultancy. He'll be speaking on the lessons learned from the application of remote operation centres in mining operations in Australia and Americas. He is a digital transformation champion.
Thank you. First of all, I'd like to thank Arthur and the team for organising such a great event again today. First of all, I'm going to give you a little bit of an overview of who StepChange Global is and what we do. We're dedicated and an independent digital transformation advisory and consultancy company. It's all we do. We've been doing this since 2008. The majority of the team have oil and gas discipline backgrounds, so we're operators or we're maintainers or we're reservoir engineers, drillers, that sort of background. And we develop digital transformation strategies, programs and pilots for all different types of organisations at different scales. So we did the original digital transformation strategy for Petronas in Malaysia, but we've also worked with tiny startup companies in Pennsylvania who've got one well. And we do everything in between, and we're very, very flexible about how we go about that. What I'm going to be talking about to you today is Integrated Remote Operations Centre Design and Implementation, which we've done a huge amount of in oil and gas. We've done a significant amount also in mining. We've done over 50 or 60 designs over the last 15 years. We've got a library of designs, and we're very proud of the work we do. We are agnostic and independent to technology. What we care about is what you do with data and information, not where you get it from. And this comes from the fact that a lot of companies already have data and information, and frankly, they're just not using the data and information they've already got. And that's where we try and focus on. We see this very much as a change problem. So digital transformation should be digitally enabled organisational transformation. It's about how you change the way of working. It's how you change what you do on a daily basis in your operational assets. And that's around people, process and organisational change. Technology, very, very important, needs to work, needs to be easy to use, but it's the enabler. Just because you've got that doesn't mean to say that you're going to maximise the benefit from your technology spend. We've had the pleasure of working with a lot of the biggest and best companies in the digital transformation space. If you dial back to when we started out in 2008-9, Statoil, which is now Equinor, of course, was our primary client, and they were really a digital pioneer in this area, along with companies like BP and Shell and Total. We've also worked with lots of small companies in the US, Canada, and Australia. We would say there is a digital hotspot in Australia. There's no doubt about it. We spend a lot of time transferring knowledge from the North Sea to Australia, and now I would say Australia is overtaking most other places on the planet. And there's a number of reasons for that, but we've worked with all of those companies there. And then about 10 years ago, we actually got asked to work with BHP. We'd already done a lot of work with Santos and Origin and Woodside. And if you know Perth, those offices are literally 100 metres apart. And so we literally walked across the road and started working for BHP on the advice of Santos. And we got involved in working with their first integrated remote operations centre, the IROC in Perth, primarily because nobody was providing the kind of expertise and background that we had in oil and gas in mining at that time. We've since then worked with BHP in a number of projects, including Escondida and the Jansen potash mine, and we've also worked with other companies in South America, including Barrick Gold, Teck, Antamina. We've done lots of these centres. This is just a fraction of the ones we've done. Some of them are tiny. Some of these ones are very, very small, and for very, very small companies, and literally cost you a few tens of thousands of dollars to get them up and running. At the other extreme, we've got some of the big mining companies spending multiple millions. But what I would say is common about all of these centres is if you get it right, they pay back typically in 3, 6 months, 9 months, or even certainly less than a year. And many of these centres we've seen them pay back in a matter of weeks, including the BHP IROC. That one paid back for its entire self in less than 5 months. And that was around the business case was 1 extra train of iron ore every month at $5 million a train. After 5 months, they were getting 1 extra train of iron ore every 4 to 5 days. So instead of taking 2 years to pay back, they got it all back in 5 months. And by the way, that centre came on when there was no AI, there was no ML, there was no digital twins. You could hardly integrate the data. The technology was relatively crude compared to what it is today. But what it shows you is the co-location of the right people looking at the right data at the right time and collaborating together can make a huge difference on the transformation of an operating asset. So first of all, what is integrated or remote operations? It's about applying all of these digital technologies to everything you do in your operation. So that's production, that's maintenance, that's logistics, it's planning, it's integrity, it's everything that you do. And it's how do you apply those technologies in a structured way to transform your operation, in this case a copper mine. However, what if you're an engineer sitting in the engineering support team, how does your day-to-day life change? Well, what we would say is you see things speeding up. There's a move to a real-time or near real-time way of working. Secondly, you might be working remote from the operational site, whereas you would have been there previously. You might be in a remote centre. And so there's connection of one or more remote sites. And if you include third parties, it can be multiple sites. And what we're seeing is the evolution of networks of centres which are within and without the company and which are global or regional. You see there's a move to a multidisciplinary way of working. So if you want to do integration of the value chain from the mine all the way through to export, that involves geologists, geophysicists, drillers, facilities people, maintenance people, truck drivers, all the way through to maybe a port system. And so it's inherently multidisciplinary. And also we see that the benefit, certainly in mining, is integrating the value chain. Very, very important, this. If you measure data and you need to transmit and store data, that's what you need to take from the equipment which is in your operation in the field. Now, if you dial back 10 years ago, the cost of doing that was extremely high, and so it was only the big boys who had deep enough pockets to be able to do this. The Rio Tintos, the BHPs in mining, the BPs, the Shells, Totals in Exxon Mobil's in oil and gas. But what we see now is certainly with IIoT, the cloud coming along, the cost of storage plummeting, that now most companies can afford to have the data and information. The important thing is, what do you do with it? How do you change the way of working, and how do you build the understanding, do the analysis? And that analysis could be good old engineers looking in screens, or it could be artificial intelligence. If you do the analysis, but then you need to identify an opportunity to do something different to improve your operation. So once you do that analysis, how do you actually get it implemented in the field? And what we see is the big gap often is that building the trust between people who work in the office, who might have PhDs and maybe technically very, very strong, and how do they convey that decision and work with the people in the field to actually implement what they've come up with. And without a decision, you don't get a value. Here, just wanted to show a few of the centres that we've been involved with. This is the first one we did in mining 10 years ago, which is the BHP IROC. This one's based in Perth. And what you see here is you see the greeny colours are actually mine control centres, with a pink team, which is the intermine management team. The green ones on the right-hand side are the rail control guys, and then the blue ones are the port in and out. And so what they did is co-locate all of the controllers from along the entire value chain, and that's how they got their benefit. There was no full data integration system. They were all using their separate systems at the time. And what they did was they spent time to write down the process of how they would integrate across this value chain, and then they built the data and information system after they worked out what the process is. So our message from this is, use the data and information you've got. You don't need the latest and greatest fully integrated perfect data set to start. Operators are used to working with dodgy data sets. That's what we do. So just start and co-locate the right people in the right on the right timescale, and you will get a huge amount of benefit just from that. Here's another one, BHP Escondida copper mine in Chile. So this is the largest copper mine in the world, as everybody knows. So we did this one about 5 years ago. Here's one for Barrick Gold in San Juan, Argentina. There's videos on YouTube about this one if you're interested. No, sorry, I had no video. I thought I'll let you down by not having a video, but there we go. This is one we've done in Chile, latest and greatest one we've done in Chile, which is a brand new copper mine. And this one involves a lot more maintenance and engineering support than just the control and the value chain stuff. And this is the latest one that we've done in Peru. for a company in Peru, and that's a nationalised company, so you can do it with a nationalised company. This one's going to be online sometime September next year. We have a process for laying this out, including understanding discovery and understanding what you're trying to achieve, but there's very much what are the processes you're going to run in there: production optimization, engineering, maintenance support, integrated planning, integrity management. What's the technology, data and information you need to enable those processes to be done remotely, real time, in a quality way? Most importantly, what's the organisational design and governance? How are you going to make decisions, and how does that change because you've got a digitally real-time remote operation? And of course, you design your IOC, and then you've got your program management, change management, organisational coaching. And the rule of thumb is if you're not spending between 15 and 20% of your budget on the change management, you're likely to fail. And there's a bunch of data, certainly in oil and gas, to back that up. So finally, these centres are well established. There are drilling centres that have been around for over 20 years in oil and gas. There are plenty of them that are more than 10 years old. We worked with BHP on the first one in their portfolio over 10 years ago. We've got plenty of them to show you. This is a standard way of working, but it's not one size fits all. It's very culturally and organisationally dependent. It depends very much on the processes you want to run. And it's really about people, process and organisational change. Value can be very high, and it is sustainable. We've seen that now. We've got plenty of evidence on that. And if you need business cases, come and talk to us. So that's all I've got.
Thank you very much, Tony.
Thank you.
So everyone's using up all their entire allotted time speaking, so maybe we'll have a bit of time at the end for questions. Next up, keeping with the digital theme, we have Hannah Lang, Team Lead Digital Solutions, excuse me, for MineSense, who will be talking about data-driven mill-to-mine optimization. Over to you.
Great, thank you, and thank you all for sticking it out until the end of today's session. So before I get started telling you about MineSense, I just want to see a show of hands with everyone who has heard of MineSense, knows anything about the company. Okay, good. So even some of the people I haven't talked to yet. So MineSense is a tech startup out of British Columbia, Canada, and we're operational in 12 mines across North and South America. Primarily, we've been operating in open pit copper mines, but actually our technology can span across a number of base metal mines, and we're starting to trial our system underground. And globally, we have about 30 different mines trialing our system right now. So I think if you haven't heard of it, hopefully you'll start to in the next couple of years. So basically what our company does is we put X-ray sensors on the front of the most destructive place on Earth, which is right in the front of the bucket of shovels. And so when this startup originated out of UBC from a PhD student's thesis, I think most people thought it was a completely ridiculous idea to try and put lab quality sensors on the front of a shovel. But where we are now is these sensors, which you can see just in the front of the bucket of the shovel on the left there, actually have a shelf life of about 50 days on average now, which means that you can put them into the planned maintenance schedules of a shovel. You don't have to take a shovel down in order to replace the heads as they need to be replaced. And this is huge for meaning that we can actually come to a mine, install our system, and not impact operations whatsoever. We also have our belt sense technology, which is where we take those exact same sensors and we put them over top of the belt in a grinding circuit, so we can measure the material as it's flowing under the belt. And we have our digital platform. So all of the data is being acquired in real time. It's directly integrated into the fleet management system or downstream in the advanced process controller digital twins. But the data is also streamed to the cloud in semi-real time as long as connectivity is there, which means that we can further analyze the data and provide insights of the entire ore body as the data is being collected. So just to look at how this technology works, on the left you can see that each head or each sensor is equipped with an emitter, a detector, and a laser. And we usually equip each shovel with 2 to 3 sensors for robustness, so that if one ends up being hit by a rock and needs to be replaced, we have a couple there. And so if the video plays, yeah. So on the front of that shovel is the sensor, and the laser detects when the material is in range, and so the emitter and detector are only scanning while the bucket is filling. As soon as that bucket is filled, all of the onboard data, the data is processed on board the shovel, so we have all of our software on that panel on the shovel. So by the time that the bucket empties into the truck, there is already a grade associated with that bucket. We're also integrated into the fleet management system, so in real time, as soon as that truck is filled, all of the bucket readings are aggregated and the data is transferred, so without any assistance from the operators, the truck is now being directed to the right location. So every time ShovelSense classifies a truck as either ore, waste, or you can even decide a number of different ore types, you can use NSR calculations and all of that to determine the classification of the truck based on our readings. That truck is then rerouted, if it needs to be, to a new destination. And every time that happens, we call it a truck diversion. So I'm going to show an example of these diversions in real time from one of our longest standing clients. This is a copper mine in British Columbia called Copper Mountain. Now they have all of their shovels equipped with ShovelSense, including their front-end loaders that dig in stockpiles. They also have 2 belt sense systems. So they have the full mine-to-mill vision installed. And so these examples I'm going to show you are from this site. So here we actually have a aerial view of the blast hole data from one bench. You can see on the left there, it's actually a video if we're able to click on that. I don't think it will go on its own. So you can see the blast hole data comes from that bench that's about 2 benches down from the top. And what you're looking at is mostly high-grade ore with copper grades up to or greater than 0.4% copper. British Columbia operates with a very low cutoff compared to most regions of the world, so this mine's copper cutoff is 0.15% copper. And that high-grade ore zone is straddled on either side by waste. It's actually a region of the deposit that was underground workings from the 1950s that then was backfilled, and what used to be the highest grade waste zone is now, or what used to be the waste that was backfilled into the mine is now their highest grade ore zone. Oops. And so then we can overlay on top of that blast hole data the ShovelSense measured bucket grades. And so now you can see the resolution when you can get a measurement of every single bucket colored by the copper grade of that bucket. And what's interesting to see is that actually this is a region where there's not a big difference between the blast hole data and the bucket grades. There's really good alignment there, probably because the stope material didn't move too much during blasting. Sometimes we see blast movement up to 30 or 50 meters, and so where the blast hole data had designated an ore zone can be completely moved from where you actually end up seeing it. Yet there was still a lot of opportunity for detecting trucks that needed to be rerouted. And this is because not only does the blast hole data have to be accurate, but you also have to draw dig polygons in a way that that material can be mined out. And this can be quite difficult when you're looking at a 2D projection with 7-meter space in the blast hole data. So you can see on the left, the mine plan had designated a few different ore polygons. And then with ShovelSense, you can see where actually all of the ore buckets fell. And so then we can overlay roughly the position of all of the trucks that were rerouted as we dug through this bench. It was about 20 days of digging, and over this period of time, you can see on the top plot is the shift average grade between the blast hole and ShovelSense readings. So there's really good alignment on the shift level of ore and waste. In the middle plot there, you can see the truck grades, where all of the solid filled yellow and red trucks over time are aligned trucks. So that means that the ShovelSense classification of the truck was the same as the mines. All of the little circles with crosses in them, or in the diagram where I have the red or yellow circles, were trucks that were rerouted. So you can see a huge amount of trucks diverted to ore. in that transition zone that was not specified by a polygon, and a number of waste trucks as well that were able to be pulled from having to be processed. And so over these 20-so days, there were 69 trucks diverted to waste that otherwise would have had to be processed at an average grade of 0.07, so almost half of their cutoff, and 171 diversions to ore with an average grade of 0.31, so double their cutoff. And this would not have been possible without getting these bucket resolution measurements, so a data set that we've never before been able to have access to. So that was one of our mines that we've been working with. This is just an aggregation of across 9 different mines since we started operating with them up until midway through this year. I think the data we collected up until July. And on average, for the trucks measured, or the trucks that were fed by measurements from ShovelSense, 7.2% of those trucks were diversions rerouted to ore, so you're improving your amount of material that you can process by 7.2%. And then 5.9% was dilution reduction. So 5.9% of all of the trucks measured would have been processed, although they did not have copper or the element at an economic grade. And this equated to between 500 and 9,000 tons more copper per year, and an additional $3 to $50 million worth of copper concentrate, depending on where we're operating. You know, a mine like Antamina has a much higher cutoff, so every single truck is worth a little bit more. And so not only is this allowing us to divert ore material to the mill that was otherwise classified as waste, so you're extending your life of the mine as long as that percentage of ore recovered is more than the dilution reduction, which on average we tend to see it is. You're also preventing the waste material from feeding the mill. And this has pretty significant downstream consequences as well. And so it allows you to increase your head grade because you no longer have to process waste. And it also allows you to reduce the variability of material entering the mill, which impacts downstream recovery. And so at that same mine, I showed the example of Copper Mountain. Because we have every single shovel and front-end loader equipped with the system, it means we have full visibility of the material entering the mill, and we're also preventing all of that waste from being processed. And so when we actually took a look over the 3 years that we've been working there at the impact that our system has had as we've seen more and more of the shovels come online with our system, we've seen huge improvements in not only the concentrate grade of the material being processed, so shifts where we had less than 20% coverage, so this was before we had our system fully operational, and maybe you were only feeding the mill that day with one system that had ShovelSense. During those shifts where there was less than 20% of the coverage from ShovelSense, on average the concentrate grade was about 23% copper, and the recovery was about 80%. On shifts when we had 80 to 100% coverage, so as we've equipped all of the systems with ShovelSense, we've seen recovery improve by about 6% up to about 86% on average, and the concentrate grade increase up to 28%, so a 4% increase there. And so that's purely just by equipping the system, not even changing operations at all to try and further reduce variability. And what we're starting to do now with our digital solutions, which is the team that I manage, is we're looking at not only predicting grade, but applying machine learning to our XRF data so that we can predict the density and hardness of material, the mineral speciation. So we've had a lot of success in predicting if the material is dominated by chalcopyrite or bornite minerals, which has direct impact to downstream processing. With BeltSense, we've been able to predict the grindability of the material. And all of these additional data sets that add on to the grade can be used to further improve your mine-to-mill optimization, to feed into digital twins, and to use that data to improve the efficiency of mining in all aspects. Thank you.
So we have a couple of minutes left for questions. If anybody has any questions. Gentleman at the back. Gentleman at the back.
Microphone for 1 second.
Microphone. Come on, Arthur. Can't keep a young lady waiting.
I think I'll be able to hear if you just want to speak up.
Most of the translators, but I'm not sure there's any. My question was just going to be about the, have you done a reconciliation of your shovel, what you measured in the buckets, against what the mill has done?
Yes.
Obviously you have, but you didn't make that point, so I just...
Yeah, I wish I had more time, because a lot of what we've been doing with our digital solutions is tracking grades from the mine all the way to the mill. We can do that with belt sense really easily. So if you put belt sense right after the primary crusher, every single truck that gets fed with shovel sense, you then get a new independent measurement. Now it is with our own sensor, so there could be biasing in theory if that was your concern. So we also then correlate our grades to the on-stream analyzer, which is an independent XRF and assay system, and we can prove that our measurements feeding the mill are much more accurate and unbiased than, for example, the blast hole data feeding the mill as well.
Thank you.
Thank you very much. I have a quick question, if that's allowed. Obviously minimising the throughput of the mill, or maybe exchanging it for higher grade, minimises the waste, so there's a direct impact on tailings, so or the volume of tailings. As a tailings engineer, I think it's quite an exciting way of doing me out of a job. So, anything to say on the if you've seen a direct reduction in material that ends in tailings?
Yeah, we haven't measured tailings yet, but we know the impact of feeding higher grade material. One interesting thing when it comes to tailings is one of those prediction models we built is measuring the neutralization potential ratio of the waste, or separating waste based on if it's non-acid generating or potentially acid generating. And so actually we can do the advanced ore sorting, which is mostly what I showed, but we can also do advanced waste sorting and measure the impact of any sort of neutralization potential on the material entering the mill as well.
Brilliant. And then being able to minimise the amount of waste that would go to, that could be classified as potentially acid generating. Oh, time's up.
You used up the last time. But yeah,
Thank you very
that's
much.
really exciting.
Right, and so to our next presenter, which I've got to switch to my notes for. Apologies.
It's a tongue twister, Richard, but...
yes. Abhisek Roy.
Abhisek Roy, yes.
Abhisek Roy.
Well done.
Head of Marketing of Orica. We all know Orica for seeing your explosive vehicles around every mine we work on.
Right.
Maybe you've got something else to talk to us about, but particularly your role in making mining more efficient. Over to you.
Sure, thanks Richard. And thanks very much, because I'm not the last man standing between the networking event and this session. So thank you very much. Really glad. Just to make sure that I understand the audience, show of hands who knows about Orica. Okay. All right, thank you. Let's go to the next slide. All right, I'll not delve too much into who we are. Essentially, we are an explosives and technology solutions company. Globally, we are there in about 100 countries, and we are established pretty well. Given the Central Asian theme, we have been established pretty well in Central Asia, more so in Kazakhstan. Over the last 20 years, we have got our manufacturing facility for detonators in Ust-Kamenogorsk. We have got 3 bulk manufacturing plants there. We also have a packaged explosives plant. And we are certainly very keen to start growing further in the Central Asian area, into Uzbekistan and Kyrgyzstan. So that's who we are in terms of a company. Just going into a couple of themes that I wanted to highlight before getting into the interesting part, which is how we are actually trying to make mining efficient, which will be around the digitization as well as the automation theme, which is the exciting part. But just on the reliable supply, given the presence we have globally, we have been able to navigate this entire crisis that we have had in various parts of the world around supply of products and services, and that's been one of the key things that we have been able to establish with our customers. Going into delivering value, and that's where the focus is. In fact, in 2021, we, as a company, defined the digital business as a separate vertical. And what we did there is we have been trying to have an end-to-end solution and trying to cover all the different elements in the mining value chain. So if you look at the right from the start, whether it's ore body intelligence, so we have been able to, it's been a combination of developing software in-house and hardware solutions in-house, but also going through an acquisition route to buy a number of companies that we have been able to acquire and bring them in so that we can, we call the string of pearls, we can bring all of these together to make sure that there is the end-to-end digital solutions that we can actually provide to our customers. Be it, the gyros and the drill-mounted sensors as the axis and the Rhino solution, which helps us actually pick up the geophysical data while we are drilling, as well as the spatial data through the gyros. So that those have been two very, very good acquisitions for us to be able to cover off the ore body intelligence piece, and we will be advancing that further as well to start seeing whether we can actually do in situ assay. Going into the design and modeling side, Blast IQ, which is our design and modeling software, which has been there, is a cloud-based platform, and which basically is where the information is fed both from downstream as well as from upstream to make sure that we have got the most efficient design and the most optimized cost position. Similarly, going down in terms of measurement through fragmentation, frag track, which is a shovel conveyor. We are producing a number of different models of frag track installations, and that measures real-time fragmentation data, which is fed through cloud as well, and which helps us optimize blast design. Similarly, ore track is a RFID. There are RFID tags which are in the drill holes, and it actually helps us monitor the grade of ore from the mine to the mill. The ground probe and monitor IQ, these are the radar systems that we've got, which have been there, which operate within the company, but has been there in operation for a long, long time in the business, and they are really path-breaking in terms of the accuracy of data that they produce. OrePro 3D is the other one which has been very successful, certainly in this part of the world, in Europe, Middle East, and Africa. What it does is it uses the block model, in situ block model, the post-blast topography, as well as the data that's available from blast designs to be able to predict the ore polygons post-blast. So that's something which has been getting a lot of traction from customers. And to bring all of these together is the IES, the final one which you see here. It is the Integrated Extraction Simulator, which basically is a software which helps us feed back information from the blast design elements into downstream to make sure that these settings in terms of both crushing and milling circuits, they're adjusted to produce the least cost of metal that we can have as an output. So that's the digital solution piece, very interesting and exciting area. The other piece, which is other thing which we have been working over the last 10 odd years, is the last piece of the puzzle in automation is blasting. How do you automate blasting? How do you make sure that you are not able, you don't have any person exposed to the hazardous blast environment? And in that space, the wire, which is the detonator wire, has been a roadblock for us. How do we make sure that we are able to remove that, have a wireless solution? And that's what WebGen, which is the world's first wireless initiating system, provides. Imagine mining where you can load your entire stove and you can fire those rings as you want without exposing anyone to the mine face. That's what WebGen provides. It has actually enabled miners to start looking at different mining methods which earlier were not possible with wired detonators. It is also a big enabler to automation, as I was saying, but this is semi-automation. We're not talking about 100% full automation. And as a solution there, we developed together with EPROC what's the world's first industry-driven semi-automated explosive charging equipment, which has been tested and is commercialized. It was tested in the Kittilä mine in the Nordics, and that's something which is readily available, certainly for certain specific conditions. So just in terms of these are the couple of things which we are working on. I'm there for the networking event. If there are any questions, please let me know. Yep.
Thank you very much. We have a couple of minutes for questions. Or we're 2 minutes nearer. Oh, okay. That's right.
Is that on? Is that on?
No.
Right. That.
Oh, you're near enough.
Just a question on diggability, and are you linking the blast fragmentation to the ability of the shovel to be able to penetrate the mud part?
Yes.
And get feedback and everything? So
Yes. So the fragmentation piece is primarily linked to. So you have things like CyclePro, which will help you to measure the shovel cycle times. So that, together with the fragmentation data through FragTrack, helps you in terms of, you can integrate that data set,
Okay. No
Other
more
questions? Thank you.
Okay, we shall move on to our last speaker.
Thank you very much.
So our last speaker is Andrew Fulton, who is president of the Mining Association of the UK. The association represents, I think it's 28 mines across all of the 4 home nations, across 12 mineral types. Over to you, Andrew.
thank you very much. And yes, I stand between you and a beer or a glass of vodka, whatever is your choice. Thank you very much for the opportunity to present to you. I'm not pitching any products. I'm going to present to you a case study of how the UK mining operators have come together to collaborate to address their concerns around health and safety and taking up the mantra of responsible mining. The world, our ever-changing tapestry of natural minerals, communities, governments, businesses and consumers. In addition to established minerals, the world is experiencing a diversification in underground mining and other subsurface extraction methods into minerals that support the decarbonisation and modernisation of energy and transport. All this alongside the need for feeding a growing global population. Of course, with this ever-changing picture that is geopolitics, these are now more commonly referenced as critical minerals, yet we all understand that it is a combination of the two, essential and critical minerals. We certainly need our mobile phones, but we also need the properties that we live in. We need the aggregate to build our roads and the salt to be spread on the roads so that our Tesla vehicles don't spin off at the first sign of a frost. And it is the opinion of myself and many of our other presenters that consider the development of these new mineral resources, there is a need to increase current production capabilities to meet these growing demands. It will lead to the introduction of new technologies and techniques. But it's more importantly recognised the need for employees at all levels to develop the appropriate levels of competence concerning the tasks that they undertake and the responsibilities for health and safety, risk control within their areas of responsibility and activity. The combined principles of effective environmental stewardship, health, safety and business performance depend on the competence of entire workforces, including management and supervisors. Today I present a case study of the experiences of the UK mine operators, a strategy of mining leadership. It was mentioned earlier, the Mining Association of the UK, and of reference there is a mining sector in the UK, and it's currently made up of 28 mines across 12 different minerals, a mix of essential minerals and critical minerals. It's consulted by government departments and other authorities. We promote best practice guidance in all matters of ESG, with a core focus in major hazard management. We also provide mutual aid in the case of emergency response and recovery, also in training, and provide technical networking visits, and of course a good bit of fellowship. We're made up of numerous well-known names and some smaller that you may not be familiar with. For example, the aggregates company Saint-Gobain's ownership of British Gypsum, through to Europe's largest mining development there is today, Anglo-American's Woodsmith operation, onto a coal mine in South Wales that actually the coal from that mine purifies 10% of the UK's drinking water due to its high carbon content. Also, we're looking at future mine type developments such as radioactive waste management that are seeking to determine where and how to establish a geologically stable deposit for nuclear waste. There is one, unfortunately, member of the team here who is recently looking for future funding, but we do offer them the support to get back on their feet in the future. You can have, of course, seen that Cornish Metals was mentioned earlier in some of the investment presentations. It is our strategic threads that are guiding us to realise how will we speak to the general public to improve mineral awareness, how will we promote amongst ourselves to meet the expectations for responsible mining, how we will develop and attract and develop the future miner from a diminishing pool of interested people within our schools today, with the various different commentaries that they're listening to around the negative connotations of mining. Once recruited, how do we ensure competence? How do we adopt technologies and see that there is sufficient infrastructure in government regulations and guidance such that we can maintain a buoyant industry in the UK? But these 6 strengths cannot be delivered together. Mork recognised the value of collaboration, and all of these organisations are people that we work with, attending conferences such as this to network and understand the needs of the sector and how we can support and amplify the messages that we all share, and how we might form combined shared resources to underpin any particular activity. How do we direct good intent? We've established 4 critical forums from leadership, qualifications, education and engineering. The first, the Mining Industry Leadership Group, is setting out the policy for operators to determine what responsible mining looks like beyond just the management of major hazards and all areas of ESG, particularly now around long-time health exposure, long-time exposure for regions, effect on biodiversity. We heard earlier also the recognition of the importance and value of other resources such as water. We write industry guidance developed by those in the field. We have it peer reviewed and then make it available to ourselves and also to our peers and anyone else operating in the UK. So if there is a new entrant in the UK mining sector, they can come and take existing guidance to establish themselves, establish their footing and the design principles for their future operations. The Mining Qualifications Committee works alongside the regulator, training providers, assurance providers and tertiary education at the Camborne School of Mines to establish and set standards of competence in mining operations to see that there are safe and responsible decisions and actions from entry point to leadership. Who is it that's making the decisions at 2 o'clock in the morning? Is it you, or is it those that you command control of your operations? And are they competent and are they capable of making those decisions on your behalf? And they are at all levels, from miner through to manager, and we've outlined exactly how each one of those pathways will connect, also offering an insight to new entrants about how they would progress and develop themselves across the sector. It is underpinned by accredited qualifications that are in mining supervision to safe entry to the works, also the mechanical and electrical technicians. We're developing that further into the more technical roles around the geosciences, ventilation, etc. Within also the Mining Qualifications Committee, the UK faced a situation where we were no longer training mining graduates through a full-time degree engineering course, to establish a degree apprenticeship which now allows for a blended learning of both in the workplace and through tertiary education. And we've created the workplace as our classroom. And the mutual aid support allows for individuals from one operation to take their experiential learning from a peer operation to increase the quantity and quality of the pool of talent across the UK. The Central Engineering Forum establishes common and best practice for engineering design, use and maintenance of mining within mining operations. It includes not only operators, but connecting in with the supply chain, the regulator and professional bodies. We understand what are the emerging technologies and what systems of work would need to be in place in operations to ensure those technologies can be quickly adapted and adopted and put to good practice. And also to secure a resilient supply chain by allowing the supply chain the understanding of what's required by the operators, but also to see where supply chain may have some weak points and substituting that with further competence and capability within the supply chain to see that the operators are not left standing without support. Now, the Mining Education Forum is the one of most interest and excitement. This is a national effort to bring together key stakeholders, to collaborate, to amplify the messages that are shared between existing mining engineers, current future talent, regulators, associations and the like, to see and aspire to developing a vibrant and comprehensive mining education programme in the UK. We recognise that there are many commentators spelling many a different truth about how the sector should be seen. We've seen people preventing our students going to career fairs. We identified a significant gap to supply the future talent of the emerging needs of the critical minerals, and there is certainly a perception that mining has lost its lustre. How are we addressing that is the establishment of a framework with an organisation called Minerals Matter, as a collaboration of organisers and organisations to showcase the opportunities and challenges of working in the minerals industry in the UK. And this works on networking STEM ambassadors, geolocating them across the UK such that they can be quickly mobilised to speak to schools and education institutions promoting the mining sector or the base subjects that we would be looking for to recruit into the industry. STEM being science, technology, engineering and mathematics. Of course, as I said earlier, it cannot be done without collaboration across the sector and with the many participating organisations. But it's important to recognise when you're establishing a collaborative framework, it's not done overnight. It's important you start communicating, coordinating and cooperating first. I think that this afternoon and this evening's networking event will be the first stage of future collaborations, and I wish you all great success in building collaboration internationally, because the mining sector is one that depends on the support of each other, peers, from one end of the value chain to the other. The mining sector in the UK has recognised the need for leadership. It is across all types of minerals. It will support the early adoption and innovation of future technologies, but most importantly, recognise the need for developing future talent and ensuring competence within the organisations that make up the UK mining sector, because it's through our people that make our sector so great. Thank you very much, and I will take any questions.
We do have a couple of minutes for any questions for Andrew or for any of the other presenters this afternoon.
Yeah, actually, I have a question, but I will speak without mic. I'll try to speak louder. I'm more interested to learn about. Hold on a second. We have a microphone. That becomes cool.
Speak. Stand next to me.
I'll do it.
Sure.
Thank you.
Okay.
Yeah. Yeah. Thank you for a very interesting presentation. Actually, I'm interested to learn more about your mining education forum and whether you have international partnerships or cooperations with other countries. If yes, so in which jurisdictions? If not, we're willing to chat during the networking and so see how we can work together. Because for my organization, education in mining is very important. Actually, we have a separate commission on education, and we are trying to, actually, one of our founders who is based in Canada now, they are trying to establish contacts with Metso Canada, and I myself visited Canberra School of Mines in March this year. And so these are the two main institutions that we are trying to work together, but I think through your organization, I think it would be much more efficient. Yeah.
Thank you very much. It's a really good question, because the problem doesn't just lie within the UK. The Mining Association of the UK brought together UK operators alongside international operators to develop a modification of the UK degree apprenticeship for the Campbell School of Mines to offer an international blended learning opportunity. It's been picked up by Perth University and also the Mining Association of Canada as being potentially a case study for future education. In South Africa, University of Johannesburg used to run a similar program, and then they went back to full-time courses. And we think there's a new place, a position for that blended arrangement for organisations to bring, well, let's say Campbell School of Mines to provide the technical programs, and then students to take on the practical experience with support of lecturers on their home base, either in their own sites or those of their peer network. So there's plenty of examples. I'd be happy to share those. Yep. And there have been conversations. I know Saudi Arabia and also I think it was Egypt and others are looking at Campbell School of Mines and other European-based education programs that can be sort of blended together with the local education programs. Yeah, let's share some further stories. And the Campbell School of Mines does have a blended program in place now, so it is available.
Thank you.
Thank you very much. That's about all the time we've got time for. Just a couple of comments, from me on the afternoon session. I think what's come through is an exciting time for for the digital transition. The contribution of that digital transition to responsible mining is absolutely paramount. But overall, also enhancing safety, as a lot of the presenters have made comment on, not just through Eurasia, including the UK with the efforts there. And the last comment, the shortage of talent in our industry is something that absolutely requires urgent addressing. And I'm very pleased to hear that there are various people around the room that absolutely agree. So with that, I'll pass you back to Arthur for his closing remarks, and thank you for sticking out the afternoon.